We continue with the last video that we did. It was on these three curves, if you remember. Fx, f dash of x and f double dash of x. Here I'll just complete this thing fast. If the function is increasing, f of x is increasing, its derivative is positive. If f of x is decreasing, that means the curve is decreasing, derivative is negative. Point P and Q are stationary point at which the derivative becomes 0. This is what we understood. And this particular point at which f double dash of x is 0 is nothing but the point of inflection. And there are some more cases to it, and so that it is easy for us to understand. So this is point A, B, C, D, E. Right? Now, from A to B, the curve is increasing. So let me write that thing for our understanding also. Right? So here what do we have is the table. You seeing this table? Yeah. So in this table, I'll say from A to B. So here we have AB. Then comes BC. Then comes CD. And last comes DE. Okay. Apart from this, here I write f of x. F of x means the curve, right? So this is f of x. Next comes f dash of x. Next again I'll write f dash of x. And finally f double dash of x. Right? So here I have this particular thing. This particular thing is nothing but f of x. This is f dash of x, the derivative of it. I have explained all this thing in my earlier videos. So that shouldn't be a problem. F double dash of x. Now, for the curve AB, you seeing this curve AB, we've understood the curve is increasing. Hence, see the derivative. Derivative is positive. Right? Understood this thing? So, curve is increasing. Here, I will mention this symbol for increasing. And obviously this for decreasing. Positive, negative. So this all is understood, I hope, right? So here just check out from point A to B as said. From point A to B as said, f of x is increasing, we know it. The curve f dash of x is positive. Now that is understood. From B to C, just check out from B to C, right? So if I just mention B to C, here I have B to C. Just understand this. From B to C, the curve is decreasing. Again, from C to D, here just checks. From C to D, the curve is decreasing again. The curve is decreasing. And we know for that case, the derivative is negative throughout, right? So I'll just mention here negative. So here the curve is negative. I hope that is understood. Negative. So it's a very, very clear indications the curve is negative. Right? Again, from D to E, just check out. From D to E, the curve is increasing and hence it has to be positive. So hence it has to be positive. So here if you check out, the curve has to be f dash of x is positive. So here if you see D to E, it was increasing and the curve is positive. I hope that's a very simple that we've taken it from the last video. Now more important, just try understanding it. Here. So if you see further, I have written f dash of x again. This particular thing. In this particular thing, I have written f dash of x again. Now what does this f dash of x here comes into play is? See, understand from A to B. Right? Understand this. From A to B, if you see, the derivative is decreasing. I'm not saying positive or negative. The derivative is decreasing and it becomes 0. Do you understand this? This particular point that we are talking about, this point is 0. Right? So it was positive and then it is becoming 0. I hope that is understood. Right? In a similar way, this is 0 and it is becoming more negative. So it is decreasing. Right? I hope that is understood. So this is maximum negative. Then from maximum negative, it increases and it becomes 0. From 0, it increases and becomes a maximum positive. I hope that is understood. I'm talking about f dash of x. I hope that point is clear. here again, right? So in this particular case, if I say point A to B, we're talking the main curve is this only. So from point A to B, the derivative is decreasing. I hope I have made myself clear. The derivative is decreasing. From point B to C, the derivative is decreasing. From C to D, right? Just check out. From A to B, the derivative was decreasing. From B to C, the derivative is decreasing. From C to D, don't see the curve, see the derivative. The derivative is increasing. I hope you're understanding this. The derivative is increasing. See this, the derivative is increasing. We're talking about the derivative. The derivative is increasing, right? And from again the next point would be from D to E, this point, right? See the derivative. So what do you see the derivative? The derivative is again increasing. So from point CD, the derivative is increasing. I hope I have made myself very clear, right? Okay. Now you just pause the video to understand the concept as I mentioned, if you don't understand at first take. Next, right? Now, what do I see further? Further, a simple concept. When the derivative is, just check this. When the derivative is, okay, I'll take the cursor, that makes more sense. Here, yeah. When the derivative is decreasing, its derivative, and a double derivative would be what? Negative. That's conceptually right. If the derivative is increasing, its double derivative has to be positive. I hope I have made myself clear, right? So here, when the derivative is decreasing, I'll just mention here, it is negative, positive. Now what are the outcomes of this? The outcomes of this is concavity that I want to explain, right? So here I want to explain what is concavity, right? There are two things. This curve, this is known as concave down. This is known as concave up. Clear? Now, when is the curve concave down? Check out. The curve is concave down where? The curve is concave down here. You understand this? And at this particular point, that is ABC, just check out from A to B and B to C. F dash of x is decreasing and F double dash of x is negative. So concave down, F dash of x is decreasing and F double dash of x is negative. I hope clear. In a similar way, for concave up, right? For concave up, just check this. For concave up, here is the curve. Concave up here. See this. Concave up from C to D and from D to E. I hope that's clear, right? And during that time, what do I see? I see that from C to D and D to E, it is increasing, right? So F dash of x is increasing. Here comes F dash of x. F dash of x is increasing, right? And F double dash of x is positive. So I hope I have explained you, okay, what are the understanding. Yes. Okay, now once I've done this, concave up, concave down, I come to point of inflection again, right? So in this case, point C is point of inflection, that is known to us. Point C is point of inflection. We've understood last time. Now, the reason behind it being point of inflection is before and after point C, right? Point C is at x equal to pi. I explained last time. At x equal to pi, right, at point C. Before and after that means f dash of x equal to pi minus some small quantity and f dash of pi plus h. What do you see? You will see, just check this, right? You will see it is negative both the ways. It is negative on both the side. That means I can say at point of inflection, before and after, derivative would be of the same sign. Derivative would be of the same sign. Right? Next, f double dash of pi minus h. Check that. What is that? It is negative. And f double dash of pi plus h. What is that? Just check. It's positive. So at point of inflection, f double dash of x is 0. At point of inflection, f double dash of pi is 0. Before and after, they will have opposite sign in f double dash. So opposite sign in f double dash. Same sign in f dash. Am I very clear with this? Just by mentioning that f double dash of x is equal to 0, that is point of inflection, is incorrect. It has to be supported with either the first clause, the first point, or the second point. The first point says that before and after point of inflection, the first derivative will have same sign, or the second derivative will have opposite sign. I hope this all is clear. So that would be all to the video. Done. So I hope the complexity is understood. Let's not get more into detail of this.